Welcome to another video from explainingcomputers.com. This time we're going to take a look at this, the Odroid HC4 single board computer, which is an interesting board because it's got two SATA interfaces. So you can connect this board to SATA SSDs or two 2.5-inch hard drives or two 3.5-inch hard drives or any combination you like of SATA hard drives and SSDs. And what all this means is that the Odroid HC4 is a great single board computer for building a small server or a NAS. And so let's go and open this thing up, and then we'll use it to set up RAID storage in OpenMediaVault. Right, here we have the Odroid HC4, which is manufactured and sold by Hardkernel for $65 plus taxes, although I purchased this one from Odroid Co UK for £83.22. And yes, exchange rates for technology products in the UK are not good at the moment. And when I purchased this, I also got its power supply, which I've got over here. This cost me £12.99, or it's $9.40 plus taxes. Let's just get it out. This is a 15-volt 4-amp power supply, a hefty power supply, and this will therefore power not just the Odroid HC4, but also two connected 3.5-inch hard drives, which is very handy if you're putting a system together. And as you can see, it needs one of those adapter things to go into a socket. You nominate the one you want when you purchase this. You don't get sent all of them. I think that's good environmentally. I got the UK one. Here it is over here. Crinkle, crinkle. Goes on, I think, something like that. There we are. So we've got the power supply for the board. Anyway, what you want to see is what's in this box. So let's open up the HC4 itself. And this is a very different type of single board computer unboxing. It's clearly all assembled. Let's get it out. Come on, like that. And it's a bit of plastic on the top. There we are. This is the Odroid HC4, also sometimes known as the toaster, for obvious reasons, because the drives slot into these slots at the top, which won't take pieces of bread, I'm sure, just hard drives or SSDs. You've got SATA connectors in the base there. There seems to be a fan at the end, and the board itself is clearly inside the HC4, the red PCB down there. Do not worry, we'll get it out, have a closer look at that later on in the video. But for now, I want to just try out how drives mount in this system. So over here, I've got a couple of Western Digital Black 3.5-inch hard drives, and before someone goes off in a frenzy in the comments, I know if you were building a NAS you would buy Western Digital red drives, not black drives, but I happen to have these black drives around, or a couple of archive drives. Anyway, if we take one of these drives and we plug it into the Odroid HC4 like this, there we are, one drive mounted like that, and I'll grab the other drive and mount it in the front slot like that. There we are. We have two 3.5-inch hard drives mounted in our Odroid HC4. And this is clear now quite a solid construction. It's quite heavy. It's not going to go anywhere sitting on the desk or in a cupboard or wherever you happen to be running it. But are these drives completely secure? Well, clearly they're not. If you pick this up and moved it too much, the drives will move around. If you drop the thing, not that you should drop your computers, but if you did, the drives will come out. I'm not sure this is the best mounting method for drives in a NAS single board computer. These type of bays are quite common, where you just drop a drive into the top, but they're usually used in situations where you're getting a drive out from a cupboard. These drives, for example, are archive drives. I sometimes get them out, connect them to something, maybe a bay like this, to actually access files, take the drives out again pretty quickly. But as you can see, I'm struggling here. Is this the best way to mount drives for building a permanent construction? I'm not sure it is. Let's try some other drives. Let's take these out like that and like that. And then over here, I've got a couple of 2.5-inch drives, also happen to be Western Digital Black. So let's take these and mount these in the HC4. One goes in there and one goes in here, like that. I think that says it all, isn't it? These drives would wobble. These drives are in. They would clearly function there. Would I use 2.5-inch drives in a system where I did that? Absolutely not. You might be able to put some sort of spacer down there, something to hold them in place. I think that's possible, but You can tell I'm slightly dubious, can't you? But let's take these out. And the other thing we could mount here is, of course, SSDs. I think I've got a couple of those around as well. So many things I've got around for you today. There we are. Let's put a couple of Kingston SSDs. We'll mount in like that. That's actually a bit firmer. They're not quite as heavy. And of course, SSDs aren't mechanical internally. So I'll be much happier taking that around, moving that around. So this is surprising me a bit. And one of the reasons it's surprising me is because I previously looked at this thing, which is the Odroid HC4. And this is also a NAS SBC. And this takes one drive, and the drives slot in here like this into this mount and go in there. And then you put a screw through the base. And this is a fantastic SBC NAS. I think this is probably the best SBC NAS you can get with the drive, very secure. And if you're wondering, there's also an Odroid HC2. I think I've got it over here. Guess what? This takes a 3.5-inch drive, which would obviously slot in a similar kind of way. Anyway, let's go back to the Odroid HC4. This mounting mechanism has thrown me a bit. It's not as good as I thought it was going to be, but this is not the only way that we could attach drives to this system. There are some alternatives, and I'll show you that a bit later in the video. So for now, what I'm going to do is to take out the drives. I'm going to take the case off. I think there's some screws under these sticky pads. So I'm going to take the case off, and we'll take a closer look at the board and delve into its specification. Greetings. Here I am back again, and as you can see, I've now taken the Odroid HC4 single board computer out of the plastic case so we can have a proper look at it, and it's a really nice single board computer. I think we should start out by turning it over because the system on the chip is on the base of the board under this heatsink, and the chip is an Amlogic S905X3, which has got a 64-bit quad-core CPU with 4 ARM Cortex-A55 cores running at up to 1.8 GHz. And it's also got an ARM Mali G31 MP2 GPU. So we've got a pretty powerful system on a chip on this board. And we've also got 4 GB of DDR4 memory. 2 memory chips are under this heatsink. 2 others are on the top of the board if you're wondering where they are. But let's stay with the base of the board for a second, because we've also here got the connector for the case fan. So obviously that gives power to the fan in the case. And we've also here on the base of the board got this, which is labelled as the boot switch in the schematics for the board. And if you think about it, this is rather strange because this is the base of the board. So when you've got the board in the case, it means this switch will pop out through a hole in the base of the case. I find this very strange indeed. Anyway, let's turn the board back the other way up because we've got very exciting things on the top of the board. Not least, we've got the 2 SATA connectors. These provide SATA power and data, and as we've seen, we can plug drives directly into these connectors, but you can also use cables to plug drives in to these, and that's what we'll be doing in the next segment of this video. Also, on the top of the board, we've got an infrared and IR receiver. We've got a couple of indicator LEDs just down there. We've got a 5-pin GPIO connector, and this is for connecting an optional OLED display, so you can monitor your board via a little OLED display. And finally, we've got a UART system console connector. Lastly, and by no means least, on the front edge of the board, we've got a gigabit Ethernet socket. We've got a USB 2 socket, so we can plug in a keyboard for checking things out. This board will mainly run headlessly, but that's useful to have. We've got a micro SD card slot for booting the board, and we've got a barrel jack for power. Oh, and just before we forget, under here somewhere, we've also got an HDMI connector. That's HDMI 2.0, offering up to 4K output at 60 frames a second. And so there we are, the Odroid HC4. In my opinion, a rather nifty specialist single board computer for network storage applications. And I think we should now move on to show you my preferred solution for connecting SATA drives to the board's twin SATA connectors. Right, here I am back again after some maker activity, and as you can see, I've taken some plastic cards, some standoffs and various screws, and I've mounted two Western Digital 750GB 2.5-inch drives on a baseboard with the Odroid HC4. And this is obviously nice and secure. It's just a fairly straightforward construction. Screws coming up under there. We can, with this construction, get to that switch on the back. You can see it in here. We can click that switch. I've actually been doing some tests with the board. It seems the board does boot before you press that switch. Not quite sure what this switch is for, resetting or something, but anyway, it's now accessible without getting underneath the board. You can activate it nice and straightforwardly with the board sitting on the table like that. And the question I'm sure you're asking is, Chris, how are you going to connect the drives from these connectors, which are designed to go directly into a drive, to these drive connectors here? And the answer is, I bought, or wait for it, some of these. These are SATA extenders. I got a twin pack of these for I think just over £7 on Amazon Co UK. Isn't it great? We can always go to Amazon. And anyway, these basically are male to female connectors. And if we fit these to the board by the magic of filmmaking, everything is connected up like this. And so there we are. We're now ready to build a RAID NAS with our Odroid HC4. Guess what? I've now got the HC4 connected up and operational, and it's headlessly running OpenMediaVault. To set this up, I installed a command line version of Debian on a microSD card before running an OMV install script. The whole process is detailed here on these pages on the hard kernel wiki, which take you through installing, as you can see, OpenMediaVault and Odroid SBCs, and pretty much what is detailed here is exactly what I showed you in my recent video where I installed OMV 5 on a Raspberry Pi. Just before installing OpenMediaVault, I also booted up with a fast SSD plugged into the HC4 and installed and ran HD parameters to test the speed of the SATA interface. And as you can see, the reported speed was about 358 megabytes a second, which means that the HC4 has the fastest SATA ports I've tested on any ARM-based single board computer. Anyway, if we come back to the board running with two 2.5-inch hard drives, we can go across to the OMV web interface. Here it is, and we'll F11 to give ourselves a bit more space. And what I'm going to do is to show you how to set up a RAID storage configuration. And to start this off, we'll go down to storage. You probably have guessed that. We'll look at disks, and we'll just see the disks connected to this system. There we are. There's a list of our 3 drives. The bottom one here is the microSD card on which OpenMediaVault is running, and these are our 2 Western Digital 2.5-inch hard drives. And if we select one of these and click on Edit, you will see I've done a little bit of configuration. I've set the drives up for minimal power usage with a standby, so they will spin down after a period of time, and I've set the spin down time to 5 minutes. Anyway, having checked our drives exist, which they do, we'll go across to RAID Management. There we are, and we'll click on Create. There's nothing set up at the moment, and we're going to set up a RAID array. I think we'll call it a HC4 RAID. Seems to be a reasonable thing to call it. We have to set our RAID level, and that is going to be mirror. So in other words, each drive is going to hold exactly the same data as the other drive. We're going to have a mirrored copy of our data to give us some redundancy. And to do this, we have to have at least 2 drives in the RAID array, as it's just told us in a little red label. But I'll click on there for the 2 drives we're going to use, obviously our 2 hard drives, and we'll click on Create. Do we really want to create RAID? Yes, we do. It'll have a little think. And there we are. We'll OK on that, and we'll apply our changes. We must always apply our changes in OpenMediaVault. And this will now take some considerable time to complete, so I'll go and have a cup of tea and come back when it's finished. And if you're wondering, it took about 2 hours to set up this 700GB RAID. So, next thing we need to do is to go to File Systems, to add a file system to our RAID, and we need to therefore go to Create in File Systems. We need to select a device, which will be the RAID we've just set up. There it is, and we'll give it a label. We'll call it HC4 RAID. Again, why not? We'll use the default file system of X4, that's fine, and we'll go OK. Do we really want to do this? Yes, we do. And there we are, it's completed, and we can now see we've got our RAID up here. There it is. It's not mounted yet, so we need to mount it by, surprisingly enough, clicking on Mount. And there we are, we just need to apply our changes. And there we are, we've got our mounted RAID. And just to test it out, I'm going to go down to shared folders and add a public shared folder just to prove the point of it working. I'll go to add there. We'll give it a name for our shared folder, HC4 share, I think. Select a device. Obviously it's going to be our RAID array. Permissions is going to be down here, everyone read write as a public share, and we'll do save on that. And then finally we'll go down to services and SMB CIFS. We'll enable SMB CIFS and save that. And finally we'll go across to shares, add a share, select a shared folder, which will be obviously our shared folder. We'll set public to only guests to make it publicly accessible to everybody. Everything else here should be fine, so we'll click on save. And in theory, we've now set up a share to a shared folder on our RAID volume on the Odroid HC4. Right, just before I bring things to a close, I'm sure some of you are interested in a performance test, and so I've mapped our RAID shared folder to drive Z here in Windows, as you can see. And running here, I've got Crystal Diskmark, where I picked up that folder, that share, as our target drive. So we'll just run just a first test here, will be fine, just to give us an idea of the speed of the system with a raw read and write. And there we are, we've got a read speed of 114 megabytes a second, write of 111, and this is pretty much what we'd expect for any decent NAS system connected by gigabit Ethernet. The constraining factor here is very much gigabit Ethernet speeds. And I suppose I should have run the whole lot. Let's run the whole lot, just because I'm sure you'll want to see it. And there we are, a whole bevy of results for OMV performance on the Odroid HC4. The Odroid HC4 is a very nice single board computer. Now, admittedly, I don't think much of the toaster design of the case that comes with the board, but we don't judge any other single board computer on the basis of a plastic case. We judge it on the specification and the performance of the board itself. And as I've shown in this video, if you take an HC4 and mount it up appropriately, nice and solid with some drives, you get very good performance. You can build a very nice NAS. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe, and I hope to talk to you again very soon.